Okay, so let's talk about arc length again. Say you have, your coordinate system, and you have some angle in standard position. Well, there's all kinds of circles, right? There's a little circle here, and a bigger circle here, and, a bigger circle here. But all of them have that angle right there in common. So because angles are rays, made up of two rays, those rays can go as long as you need them to make it big enough for your circle. So they use the word subtended in the book. It's not a word we use all the time in math, but subtended just means that you're extending the angle as big as you need to get to intersect with your circle. Okay? All right. Now, arc length, we gave that to you before, but the arc length S is equal to the radius times theta. Just remember that theta has to be measured in radians. Okay, so R being the radius and S being the arc length. Okay, so radius and arc length. Okay, so now we're going to look at this problem. Assume the orbit of Mercury around the Sun is a perfect circle. Okay, so here we have the Sun, and then Mercury is like going around the Sun in a circle. Okay, Mercury is approximately 36 million miles from the Sun. So the distance from, where's Mercury? There's Mercury. The distance from the Sun to Mercury is the 36 million miles. Okay? Million miles. All right. In one Earth day, Mercury completes 0.0114 of its total revolution. How many miles does it travel in one day? So what we need to do is figure out the circumference of this circle here. All right, we know circumference is 2 pi r, and we know the radius, so 2 pi times 36. So that's going to be, what, 72 times pi. That's about, I'm going to round it off to the nearest mile, 226 miles. Million. I meant million miles. Million miles. Oops. Okay. So, oh, no, that's the circumference. That's not the answer. Sorry. See if I can erase just that part. Oh, very good. Okay. So what we have to do is figure out 0.0114 of that revolution. So this is the total revolution. So if Mercury's going one time around the Sun, it's going 226 million miles. Okay, so that's a total revolution. And now we need to figure out 0.0114 times 226 million miles. All right, and I'm getting I don't know how many decimal places they go, 2.5, they went 2 decimal places, 2.58. I'm going to say standard if they don't tell you 2 decimal places. So approximately 2.58 million miles. All right, that's, a little ways around the Sun. Okay, now use your answer from part A to determine the radian measure for Mercury's movement in one Earth day. Okay, so it was moving 2.58 million miles in one Earth day. Now we want to know what that radian measure is. Okay, so go back to the formula for arc length. S is equal to R theta. If you take the arc length and divide by R, then you're going to get those will cancel, So S over R is going to equal that radian measure for how much it rotated in 1 Earth day. Okay? So we know the arc length, that we figured out. That was the arc length, S. We already know the radius, so 2.58. And we're dividing by, the radius was 36. They're both in millions of miles. Okay, so 2.58 divided by 36, and I'm getting approximately 0.072 million miles. No, sorry, radians. This is now in radians, not millions of miles anymore. Now, if you want to see what happened to the millions of miles, they probably don't write the word radians. I'm just doing it to make it a little clearer. But this was millions of miles, and this was millions of miles. And so what happens to the units? They cancel out, okay? And that's in radians now, 0.072. All right.